Hello student, today we are going to learn about the monostable multivibrator using 555 timer. Now this is your 555 timer. This is your monostable. The external RNC has been connected. Now this is the internal circuit of 555 timer. Now how circuit has been connected? If this is your IC, now let me draw. This is your IC. Now externally R and C has been taken, and if you draw 1, 2, 3, 4, 5, 6, 7, 8, terminals 7 and 6 has been common. This 7 and 6 has been made common, and it has been connected to across capacitor. This is the connection that we have done, and here we are supplying VCC, and this is going to terminal 8, and here also terminal 8 has been supplied with VCC, and 1 has been supplied with the ground. 2, here we are going to provide the pulse, and 3 we are going to take the output. This is 3 we are going to take the output. This is 3 where we are going to apply the pulse, and 4 will be connected to VCC. This is your circuit diagram. Now if you see, now let me erase all this one. This is your circuit diagram. Now the most important point about this 2, how the pulse is applied. Now let me, this is how the pulse is applied. Now let me draw this, means let me draw the switch. This is your switch, this is your switch S1, and here VCC, and this is the connection. Means this is your switch that will be working. Now how this switch is going to work? Now this switch will be remain to connected to this terminal 2 will remain connected to VCC for almost all period of time, but when this switch is going to get pressed, momentarily it is going to get pressed, and it is going to get connected to ground. When it will be connected to ground, then your output is going to come to terminal 2, it is 0, and when you release this one S1, then again it is going to get connected to, and momentarily it will be connected to 0, and after you release it is going to again get connected to your VCC, means again it will be connected to VCC. This is how the operation is going to get performed. Now if you see, now let me draw once again. This is how the switch has been drawn. This is the switch S1. Initially it is connected to 2. Now let us start the operation of bistable monostable mode of multivibrator using 555 timer. Now here capacitor is not connected, it is connected to 0. Suppose it is connected to ground. Now because RNC is not, VCC has just been applied, now here it is 0, and here if you see, suppose I am connecting 12 volt, now here it will be 8 volt, and here you are going to get 4 volt, because there will be 2 VCC by 3 and this is going to VCC by 3. Now 0 minus 8, what is going to give you? 0 minus 8, it is going to, non-inverting voltage is lesser than inverting, means you are going to get a logic 0, means minus into 10 to the power 5. You see this is minus V set, it you are going to get a logic 0. Now what will be the value here? Here you are going to connect a 12 volt, because this VCC is directly connected to 12 to terminal 2. 4 minus 12 into 10 to the power 5 means minus V set, means logic 0, means it will retain its state. When S and R is 0, 0 means what will be the output? It will retain its state. Now output will be here 0 only. Now what we are going to do now if you see, now next what we are going to do, we are just going to apply a pulse. Now if you see here, we are going to apply this to, now let me delete this one. Now I am going to apply S1, it means terminal 2 will be directly connected to S1. Now this is what terminal 2 was, and now momentarily for a small period of time it is connected to S1. Now it is connected to S1. When it is connected to ground, this will be 0 volt. When this is 0 volt, then what will be the output voltage? 4 minus 0 into 10 to the power 5. This is open loop gain. This is non-inverting terminal voltage, inverting terminal voltage. This is going to give you plus V set, means it is going to get to 1. When H is equal to 1 and R is equal to 0, the output will be 1 and 0. Output is 1 and 0. Now your output is going to come back to 1. Now if you draw the output, this is the output you are going to get. Now when output is going to become 1, and this will become inactive because this 0 is being applied over here. When this being inactive means there is no connection over here, because this transistor is not showing, means this transistor is not connected over here, means there is no connection of transistor over here. Now what will happen, the capacitor will start charging. Now capacitor will start charging. Now here if you draw the capacitor voltage, the capacitor will start charging. When this capacitor will voltage will try to go beyond, suppose it is 2 VCC by 3, suppose it is going to 9 volt. Now what will be the output voltage? Now what will be the output voltage? 9 minus 8 into 10 to the power 5. Now it is going to give you plus Vsat. Now it is going to be 1. Now you see this 1 and 1 has come. Now there is no state like 1 and 1 in RS flip flop. This is not a valid state of RS flip flop. But one point I told you, this is momentarily connected to ground. Once it is connected to ground, again it is going to come back to its normal position 1. Means here as soon as if this operation is occurring for millisecond, this will occur for 0.0 millisecond, and again it is going to get connected to VCC. When it is connected to VCC, what will happen, the operation will, if you see, if this is connected to VCC, now this will be your 12 volt, and this is 4 minus 12 into 10 to the power 5, it is going to give you minus Vsat. Now it is again going to come to 0. Now as an R is equal to 0 means output will be 0 and Q bar will be 1. Now what will happen to capacitor? If you see, output has come to 0. Now if you draw the output has come to 0. Now what has to happen to capacitor? This one is connected here. Now this has become active. Now this capacitor will be directly connected to ground. Means capacitor value will be also going to 0. Now this will be the our value. Now let us go and simulate on our LT spice. Now we are going on LT spice. Now for that what we need, now first delete all this one. First I am going to erase all this one. If you erase this one, here I am going to draw the your monostable mode of multivibrator. Now first go to component, here go to component, select voltage. How many voltage source we need? 2, because one for pulse and another for your circuit operation. Now let me reverse, because it will be at some point it will be reversed. Now let me select this one. Now this is what we have done. Now let us connect ground so that our circuit will be completed. Now we have connected ground. Now just go to component and select your miscellaneous, go to miscellaneous and select any 555 timer. This is the any 555 timer we have selected. Now this is the any 555 timer we have selected. Now if you want to move here, we are moving it. Now this is your 555 timer. Now we are going to make the connection. Now what was the connection? Here if you see 6 and 7 is terminal 6 and 7 has been connected here, and externally if you see, let me connect 6 and 7. We have connected 6 and 7. Now let me make connection very right. Now this is 6 and 7 we have connected, and externally R and C is being connected. This is R and I am going to select C. This is the C that we have connected, and now let us complete this circuit with the ground. This is the ground that we have connected. Now join VCC with terminal 8, and here also we need VCC. This is the VCC we have given, and one at terminal 4 also you need VCC. This is the VCC that we are going to provide. Now if you see, this is the VCC that we have given to terminal 4. Now if you see, this capacitor is going to get connected to 6 and 7. Now let me give the value of V. This is your 12 volt. This is your 1K. Now this is your 10 microfarad. Now here we need to provide the trigger, and here we need to provide the ground. Now this is the ground that we are going to provide here. Now let's select ground and make it ground. Now here we are going to take the output, and here we are going to give the trigger. Now let me decide that this trigger pulse. Now we wanted to give trigger pulse. Now go to advanced, now go to pulse. Now this is the initial value. Now which initial value we wanted? The VCC 12 volt we have given, and we want to go to momentarily for 0 volt, and we are not providing any time delay, means we are keeping everything. Now we are providing time delay. Suppose we are giving a time delay of 10 millisecond, means after 10 millisecond our this pulse will come. Now on time we are going just keeping for 0.4 millisecond, and period is also for 0.4 millisecond we are just providing, and 1 cycle we are keeping. This is the 1 cycle we are keeping. Now this is we have given the pulse. Now if you see the pulse will be, if I draw the pulse, now your pulse is going to be, means after 10 second you are going to get a pulse of, it will be a 12 volt. After 10 millisecond you are going to get a 0.4 millisecond of pulse, where the output will be 0, and again it is going to come back to 12 volt. Now if you want to see, now let me run this one. Now I think we have connected all this one. Now let us first, before going here, now just give your naming, labeling the net. Now this is your V trigger, this is your V trigger. Now this is your, I am going to connect V trigger. Now here this will be your V output, V over here. Now if you see here, this is your capacitor value. Now let me zoom to fit. Now this is the point that we were talking. Now if you want to run in capacitor, and this is your output and capacitor. Now pulse has been applied, the output and capacitor has been taken in one plane, and initial voltage is 0 volt. Now it has come to 8 volt. Now if you want to derive the expression of capacitor and the time period that for which it has come, now we have find equation with us, that Vc is equal to Vf minus Vi into e to the power minus T1 by tau. This is the T1 that we are going to calculate. Now if you see, if you keep, now where till what point capacitor has been charged, till 2 Vcc by 3. Now this value is nothing but 2 Vcc by 3. Now what was Vcc? It was 12 volt. Now Vf at till what value it was wanted to charge? Till Vcc minus final is Vcc, and initial is 0 volt into e to the power minus T1 by tau. Now if you see 2 Vcc by 3, now if you see take Vcc common, it will be 1 minus, see this is 1 we have taken, now this will be e minus T1 by tau. Vcc will get cancelled. Now let me erase this so that we can calculate here very easily. Now if you see this got cut. Now if you see e minus T1 by tau will be equal to 1 minus 2 by 3. Now this is nothing but 1 by 3, and it will be 1 e minus T1 by tau. If you take this one this side and this one this side, then 3 is going to become e minus e T1 by tau. Now take ln both side. Taking ln both side, what you are going to get? ln 3 is nothing but 1.1. Now this will be T2 by tau, T1 by tau. Now if you see T1 by tau is equal to 1.1. Now if you see T1 will be 1.1 into tau. What is tau? Tau is nothing but 1.1 into R and C. Now this is your, what was R? R was 1K and capacitor was 10 microfarad. If you see, it is going to come 1.1, this value is 10 to the power minus 6 kilo 10 to the power 3. Now it is going to come in millisecond only. See, from 11 millisecond, it is, if you calculate this one, it is going to come in around 11 millisecond. From 10 to 21 millisecond, this pulse was generated. Because if you multiply 1.1 with the 10, it was R 1K, and it is 10 to the power minus 6. Now this is going to give you minus 3, this will give you millisecond, and 1.1 into 10, it is going to give you 11 millisecond. This is the time period that we got. So this is all about the monostable multivibrator using 555 timer.